Hello everyone, I welcome you all for the lab engineering metrology. So metrology is the science of measurement which deals with the measurement of size, measurement of form and measurement of positions. And metrology is also deals the measuring instruments. So metrology lab helps the manufacturers to measure the dimensions at various stages of the manufacturing process so that they can obtain the desired type of fit and finish for their produced products. And also, so the manufacturers can minimize the wastage of the material at different stages of the manufacturing. So the metrology lab plays an important role for the student. So who wants to pursue his career in industrial engineering and shop floor control. So metrology labs list of experiments are chosen in such a way that so the students can familiarize in various kinds of measuring instruments. So the students can learn the measurement procedure in measuring instruments such as vernier calipers, micrometers, vernier height gauge, depth micrometers, and dial bore indicators, gear tooth vernier calipers, sign bars, bevel protractors, profile projectors, and also the dial indicators. So in this video, so I am going to explain so how to measure the length, height, depth, diameters by vernier calipers, vernier height gauge, and micrometers. So this is the aim of the experiment. So to measure the length, height, depth, diameters by vernier calipers, vernier height gauge and micrometers. So the apparatus required for conducting the experiment are, so we need vernier caliper, we need vernier height gauge, and we need outside micrometer and also depth micrometer. So in this, so we have chosen a cylindrical part or cylindrical component. So we are going to measure the outside diameter of the cylindrical component and length of the cylindrical component. And also we have chosen the hollow cylindrical workpiece that is called ring gauge. So for this ring gauge, we are going to measure the what is the inside diameter of the ring gauge and what is the depth of the hollow cylindrical ring gauge, and also we are measuring the height of the cylindrical ring gauge. So as you know, what is the principle of vernier caliper? So the principle of vernier caliper is the difference between the two scales, that is main scale and the vernier scale, are nearly equal but not quite alike for obtaining a small difference. So on this principle, the vernier caliper works. So the principle of vernier caliper is the difference between the two scales, that is main scale and the vernier scale, are divisions, so which are nearly but not quite alike for obtaining the small difference. So on this principle, the vernier calipers works, and the micrometer works on the principle of a screw and a nut. So in order to conduct the experiment, we need to know what is the least count of micrometers, and so we need to know the least count of vernier caliper and vernier height gauge, and also the outside and depth outside micrometers and depth micrometer. So for the vernier caliper and the vernier height gauge, so least count is equal to 1 main scale division minus 1 vernier scale division. So we can also calculate. So least count is equal to smallest division on the main scale divided by total number of divisions on the vernier scale. So the instrument which is available in our laboratory is having the smallest division on the main scale is 1 mm, and the total number of divisions on the vernier scale is equal to 50 divisions. Therefore, we will get the least count is equal to 0.02 mm for the vernier caliper as well as vernier height gauge. Similarly, for the outside and depth micrometer, so the least count is equal to smallest division on the main scale divided by total number of divisions on the thimble. So the smallest division on the main scale is 0.5 mm divided by total number of divisions on the thimble is 50. Therefore, the least count of the outside micrometer and the depth micrometer is 0.01 mm. So these least counts we can use in taking the measurements. So these are the tables which are required to take the dimensions of the components or workpiece using the vernier caliper. For this is the table for measuring the length, and this is the table for measuring the outside diameter using the vernier caliper. So vernier caliper consists of the main scale reading and the vernier scale reading. So and we have the least count. Then a total reading is main scale reading plus least count into vernier scale reading. And also we use the vernier caliper for measuring the inside diameter, and also vernier caliper used for measuring the depth of the ring gauge, and vernier height gauge is used for measuring the height of the ring gauge, and also we use the micrometer for measuring the outside diameter, and also we can use the depth micrometer for measuring the depth of the ring gauge. Now I will show the video. So how the vernier calipers, micrometer and vernier height gauge can be used for measuring the dimensions of the given components. So these are the tools or instruments required for conducting the experiment. So this is the vernier caliper, and this is the outside micrometer, and this is the inside micrometer, and this is the vernier height gauge, and so these are the cylindrical workpieces, so for which we want to measure the dimensions, and this is the ring gauge. It is a hollow cylindrical workpiece, so for which we want to measure the inside diameter and the height and the depth of the cylindrical gauge. Now we are measuring the length of the cylindrical workpiece. Now using the vernier calipers. So what is the main scale reading here? So it is 50, and here the vernier scale 0 is exactly coinciding with the 50. That means vernier coincidence is 0 and the main scale reading is 50. So 50 plus 0 into 0.02, we will get 50 mm. So I will show the final readings in the table. So after completing the video. So this is the reading from the vernier caliper for the length of the component. Next we will change the position of the component or workpiece between the two jaws, and then again we will take the measurement. So here the workpiece is placed in between the two jaws, that is fixed jaw and the mobile jaw. Now we are changing the position of the workpiece between the two jaws, and we are taking again the reading. So in the second case also, so we got the 50-50. 50 is the main scale division, and changing the position of the workpiece, and again we are taking the main scale reading and the vernier scale reading on the vernier calipers. So this procedure will repeat 4 to 5 times, and then we will take the average. Next, so now the workpiece is placed between the two jaws, and the vernier calipers is going to use for measuring the outside diameter of the workpiece. So let us see. So here this is the 10th main scale reading, and this is 15th main scale reading. Now the zero position is in between, that is 15th and 16th. So therefore the main scale division will become 15, and the vernier coincidence is, right, if you see, if you observe this, there is a fifth number on the vernier scale, right? So it is exactly coinciding with the main scale division. So 5 means, so each number is having the 5 divisions. So therefore we'll get a total of 25 divisions at 5, right? So that is, so 15 plus 25 into 0.02, that is 15.5 is the dimension of the, or diameter of the circular piece. Now we will change the position. So we'll take the readings at different positions along the length. What is the diameter? So again, if you see here, again it is 15. This is the second reading. And then if you see here, so it is approximately at the 7th division is coinciding with the main scale division exactly. Therefore, 7 means 7 into 5 divisions. That is total 35 divisions. So that this is 15 plus 35 into 0.02. That is 15.7 mm is the diameter at the second position. Now again we will change the position of the work, right, jaws on the workpiece. Again we will place the workpiece between the two jaws at a different position, and then we will take the measurement. Okay, again the main scale division is 15. Let us, if we see here, right, this is, so fifth division is coinciding with the main scale division. So that is total we have 25 divisions. 25 divisions. Fifth number means it is 5 into each number is having 5 divisions. So therefore 25 divisions. Right. So you can also observe again. So it is 15, and the fifth number is, right, fifth, that is each number is having 5 divisions. That is 25th division is exactly coinciding with the main scale division. So that is 15 plus 25 into 0.02, that is 15.5 is the total reading. So this I will show on the tabular column. So in this way we can measure the diameter and the length of the given workpiece. Similarly, the vernier calipers can also be used for measuring the internal dimensions of the component. So these two are external jaws, and these two are the internal jaws. Okay, so these jaws can be used for measuring the internal dimensions of the given component. So in this we are measuring the internal diameter of the ring gauge. Let us see how we take the measurement. So let us keep the two jaws inside the right, hollow workpiece, inside the hollow workpiece, and then we will see what is the reading. So here the main scale reading is, it is 20, it is 25, it is in between 24 and 25. So the main scale division is 24, and the vernier scale coincidence you see, right, it is up to 5, it is 25 divisions. Okay, so let us see here this division, right, 6 or 7. Okay, so it is a 30 plus 1, 31 division is exactly coinciding with the main scale. That means 24 is the main scale division, and 31 is the vernier coincidence. 24 plus 31 into 0.02, that is a 24.62 mm. That is the diameter of the cylinder, inside diameter of the cylinder. So let us will change the position of the workpiece. Again, we will take the reading. Okay. You see what is the measurement. So it is 25, right? And 0 is the exactly coinciding with the main scale division. So 25 is the main scale reading and vernier scale reading is 0. That is 25 plus 0 into 0.02. We will get 25 mm only. Again, we will change the position of the workpiece. Again, we will take the reading. Now you see what is reading. So it is again, it is in between 24 and 25. And you see what is the vernier coincidence. So let us see, it is the fifth number, that is up to, it is total 25 divisions, right? 25th division is exactly coinciding with the main scale division. So that means main scale reading is 24 plus 25 is the vernier coincidence multiplied by the least count 0.02. So we'll get 24.50 mm, right? Again, we will change the position of the workpiece and again we will take the measurement for the inner diameter of the workpiece. So we will repeat this procedure for at least 4 to 5 readings, and then we will take the average. Again, it is in between 24 and 25. So main scale reading is 24, and let us see what is the vernier coincidence, right? So it is exactly 26th division, right? Each right, 0 to 1 we have 5 divisions, 1 to 2 we have 5 divisions. So like that, the 26th division is exactly coinciding with the main scale divisions. So that means 24 main scale reading plus it is 25 plus 1, it is 26, up to 5 it is 25. The neighboring division is 26th division. So 26 into 0.02, that means 24.52 mm is the diameter of the given cylindrical component. Now we have taken the 4 readings for the diameter. So we will take the average value. So that I will show in the tables. Next, this is the micrometer, so which can be used for measuring the outside diameter of the cylindrical workpiece. Now the workpiece is placed in between the fixed anvil and the movable spindle. And then we will see the reading on the barrel as well as on the thimble. So this is 15th and this is 15.5. So here we are not reached exactly to 16. So the main scale reading is 15.5. And what is the thimble reading, right? So it is this is 30, 31, 32, 33. Okay. So we'll take 33 on the thimble reading. Therefore, how do you get the total reading? 15.5 plus 0.33 mm. 33 into 0.01, you will get to 0.33 mm. So 15.5 plus 0.33 mm. That will give us the total diameter of the workpiece. Similarly, so we will change the position of the micrometer on the workpiece. Again, we will see. So what is the main scale reading and what is the thimble reading, right? So it is 15.5, and this is 26th division is coinciding with the reference line given on the barrel. So 15.5 plus 26 into 0.01, right? So that will give us the total reading. Again, we will change the position of the workpiece. Again, we will see what is the reading. right? So here again it is 15.5. So here there is a 25th division is coinciding with the barrel reading. Again we will change the position of the micrometer on the workpiece. Again we will see. So what is the reading? It is 15.5 plus this is 21. Okay, 15.5 plus 21 into 0.01 will give the total reading. So in this way, so we will take the readings at different positions along the length of the workpiece, and then we will take the average diameter of the workpiece. Next we will take the depth of the given ring gauge by using the vernier calipers. So how to measure the depth using the vernier calipers? So we have the depth probe. Okay, so that is inserted into the cylindrical hole, and then we keep the this L-shaped element on the top of the ring gauge, so which can sit on the top of the ring gauge. So let us see the procedure now. So this L-shaped frame is mounted or sit on the top of the workpiece, and then we will take the reading. What is the main scale division? So this is 70, it is 75, it is 74 is the main scale division. And what is the vernier coincidence? If you see here, let us the first number, that is fifth division, is exactly coinciding with the main scale division, that is 74 plus 5 into least count of vernier caliper is 0.02. Therefore we will get the total reading as 74.10 mm. Similarly, we will take the measurements at different locations in the ring gauge, inside of the ring gauge. Now I changed the position. Again we will see what is the reading. So again it is 70, it is 75, it is 73, right? It is very close to 74, but it's not exactly at 74. So main scale reading is 73. And what is the vernier coincidence? Let us, if you see here, about 41 division. 41 division, that is 8, 8, 5 is 40, and neighboring point is neighboring, right? So neighboring one is 41. Okay, so 41, 73 plus 41 into 0.02, we will get 73.82 mm. So neighboring division is 41, right? Then again we'll change the position of the workpiece or position of the vernier caliper. Again we will take the reading of the main scale and vernier scale. Okay, again it is 73. Again it is 73. And main scale and vernier scale division is, so we can observe as 43. So therefore we will get 73.86. Again we will change the position and then we will take the reading. Okay, so in this way we have to conduct the experiment at different places, and then we will take the average value. Then next we take the readings using the vernier height gauge. So here we are going to measure the height of the given component using the vernier height gauge. So for that, so first we need to check the instrument for its 0. So that means the main scale division, main scale 0 and the vernier scale 0 should coincide. When the measuring unit is contact with the surface plate. Otherwise, we need to adjust this beam, right? We have the fine adjustment screw. So with the help of fine adjustment screw, we can adjust this beam in the column until to show the reading 0. Now we can see. So in this case, so we have 0 and 0, right? Exactly coinciding. Now we can use directly this for measuring the height of the, let us given component. Now we will see what is the main scale reading and what is the vernier coincidence on the instrument. Let us see. So here it is 9 means it is 90 mm. So these are represented in centimeters. So 9 is 90 mm. And this is 1, 2, 3, 4, right? 94 is the main scale division, and this is 95. Okay, and what we see, we need to see what is the vernier coincidence. Vernier coincidence. So vernier coincidence is, in this case, it is. So let us, if you see, this is the 6th number. That is 6 into 5, right? Sorry, 6 into 5. It is 30. Or let us, if you see here, this is the 7th division and this division, right? So 35, it is 36. This division is exactly coinciding with the main scale division. So that I will take 36th division of the on the vernier coincidence. On the vernier scale, we take the 36th division. So that is the vernier coincidence. So 94 is the main scale division plus 36 into 0.02, right? We will get the total reading. Again, we will change the position of the workpiece. Again, we will take the reading. Again, we will change the position of the workpiece. So we will take the main scale reading and the vernier scale reading. Now again, you see, so it is this is 0, right? 0 line of the vernier scale. This is 94th division. This is 95th division. Okay, this is in between 94 and 95. So main scale reading is 94, and we'll see what is the vernier coincidence. Okay, so let us, if you see the, okay. So if you see here, the 5th number, that is 25th division, is exactly coinciding with the main scale division. Therefore, total reading is equal to 94 plus 25 into 0.02 is the total reading of the height of the given component. So in this way, we can change the position of the workpiece under the measuring probe, and then we will take the main scale reading under the vernier scale reading, and then we will calculate the what is the total reading using the vernier height gauge. Next we will see so how the next we will see how the depth micrometer can be used for measuring the depth of the cylindrical ring gauge. So this is the depth micrometer. So these rods, we have different sizes. So this is 25 mm rod. Similarly, we have the 50 mm rod and 75 mm rod. That means when we insert this rod through this barrel, right? When the thimble is exactly at 25 mm, 25 division, then it shows the the length is, if it is 25 rod, it shows 25. If it is 50, it shows 50. If it is 75, it shows 75. Okay, but in this, the depth micrometer, the divisions are calibrated in the reverse direction. So here in the outside micrometer, we found here it is 0, and at the end we found 25. But here it is starting is 25 and ending is 0. Now we will place the measuring rod so inside the ring gauge. So this is the locking nut. So this is the locking nut. So we'll place the two fingers at this point, and then we will apply some moderate pressure to hold the micrometer, and then we will rotate the thimble. Now we will see what is the main scale reading and what is the vernier scale reading. So here the depth of the rod we used is 75 mm. Here the depth of the rod is 75 mm. This rod length is 75 mm. So when this gets 75 mm, when the thimble, right, exactly on the 25 mm line, 25 mm line, this length is 75 mm. Now it is turned back. Okay, so turned backward. How much it is moved back? It is 25. Let us, if we consider it is 0, it is 0.5, right? So this is 1, right? So 1 mm. This what is the vernier thimble division on the barrel? So it is 25, 26, 27, 28. So 28th division. Okay, that means it is 1.28 mm is moved backward. So total length of the rod is 75 mm. So you need to subtract 1.28 mm. 1.28 mm. Okay, so we'll get 73.72 mm. So let us again repeat. So this rod length is 75 mm when the thimble reading 0 exactly at the 25 mm. Okay. So but it is rotated backward. How much it is rotated back? So this is 1 mm, right? This is 0.5 mm, this is 1 mm, and the thimble reading is 28th division. 28th division. That means main scale division is 1 plus thimble is 28 into 0.01. We will get the total reading. That is 1.28 mm is moved backward. So this we have to subtract from 75 mm. So in order to get the total depth of the ring gauge. So 75 minus 1.28 will give us 73.72 mm. Similarly, again we will place the depth micrometer inside the ring gauge. Again we will take the reading. So this procedure will repeat 4 to 5 times, and then we will take the average. So here it is 1 mm plus when the thimble reading is 30 into 0.01, it is 0.3 mm, it is 1, and that means 1.3 mm is moved backward. So what is the total length is 75 minus 1.3, we will get 73.70 mm. Similarly, again we will take the reading. So by keeping the measuring rod into the cylinder. So here there is a locking nut, we have to lock it. So for taking the readings. Now again it is it is 25, right? This is one first division, that is 1 mm, and the vernier coincidence is it is 35, 36, 37. That is thimble coincidence. So that is 1.37 mm is moved backward. The rod is moved backward by 1.37 mm. Therefore, total length is 75. 75 minus 1.37 will give 73.63 mm. So in this way, so we will take the measurements using the depth micrometer. Now we will report all the measured values in the tabular column. So for the vernier calipers, length measurement, for length measurements, we have taken main scale readings and vernier scale readings, and least count is 0.02, and then total reading is calculated as 50 plus 0 into 0.02 will get 50. So in all the cases we got 50 mm. So therefore the average length is also 50 mm. Coming to the vernier calipers can be used for measuring the outside diameter. So what is the readings? Main scale readings 15 and vernier scale readings 25, 35 and 25 divisions. And the least count, right? 0.02. And then we will substitute here and we'll calculate the outside diameters at a different locations on the length of the workpiece. And the average value we obtained as 15.567 mm. Similarly, so measurement of inside diameter using the vernier caliper. So inside diameter is 24 is the main scale reading, and vernier scale reading is 31. That is first reading. least count is 0.02, we'll get to 24.62 mm. Similarly, in the second case, it is 25 and vernier scale reading is 0, it is 25 mm. And in the third case, fourth case, these are the vernier scale reading and the main scale readings, and these are the values. Now we take the average of all the four readings, so we'll get to 24.66 mm. Similarly, the diameter of the component is measured by using the outside micrometer, and these are the values. 15.5 is the main scale reading, and the thimble reading is like this: 33 for the first one, second one is 26, third one is 21 we got, and the least count is 0.01 for the outside micrometer and the depth micrometer, and the total reading we got 15.83 for the first one, second one is 15.76, third one is 15.71. So the average is 15.767 mm. Similarly, depth is depth of the ring gauge is measured by vernier calipers, and the main scale readings are like this, and vernier scale readings are like this, and total reading is first set 74.10, and the second reading is 73.82, and the third reading is 73.86, the fourth reading is 73.72, and the average value is 73.875 mm. Similarly, we measured the height using the vernier height gauge. So first one is 94 mm main scale reading, and 36 is the vernier scale division, and the least count is 0.02. So we'll get 94 plus 36 into 0.02, 94.72 mm. Similarly, the second reading and vernier coincidence values we have noted, and total reading is 94.50, and the average value is 94.61 mm. And depth micrometer we use it for measuring the depth of the ring gauge. So 75 is the length of the rod. 75 is the length of the rod, and the first reading, it is moved backward by 1.28 mm. Therefore, we will get a 73.72 mm. And second time, the micrometer is moved back through 1.3 mm. So therefore, total length is 75 mm. We have to subtract 1.3. That will give the actual depth of the ring gauge. Similarly, in the third reading, we got 1.37 mm movement backward. So 75 minus 1.3 will get 73.63 mm. So the average is 73.68 mm. So now we need to write the results under the results section. So the average values of dimensions using vernier calipers are like this. Length is 50 mm, and outside diameter average 15.567 mm, and inside diameter 24.66 mm, and depth 73.875 mm, and height 94.61 mm. And also the average values of dimensions using a micrometer. Outside micrometer we use it for measuring the outside diameter of the workpiece, that is 15.767 mm. And the average values of dimensions using depth micrometer is, depth is 73.68 mm. So then we draw the conclusion based on the results. So from the results, it is observed that the depth measured by the vernier caliper and the depth measured by the depth micrometer. Okay. So the depth micrometer will provide the accurate results when compared to the vernier calipers. So the reason is the vernier caliper cannot be positioned exactly at the center of the hole, right? So this measuring probe may sit on the top of the workpiece. The measuring probe may be seated on the maybe at the edges or corners of the workpiece. So that's why the accuracy of the vernier caliper for measuring the depth of the workpiece somewhat less accurate compared to the depth micrometer. And the applications of the vernier calipers, micrometer and depth gauge. So vernier calipers can be used in measuring the dimensions in the steel sector and also used in the automobile sector and medical industries also the vernier calipers used, and in the scientific laboratories also the vernier calipers can be used, and in the educational purpose in the laboratories we use the vernier calipers for measuring the dimensions, and also in the aerospace industries for measuring the various features of the components. And the micrometer is used for measuring the spline shaft diameter measurements, and the pipe thickness you can measure using the special micrometers, and the root diameter or effective diameter of the screw thread you can measure, and the gear outside diameters also you can measure, and the fluted cutting tools outside diameter measurement you can make, sheet metal thickness you can measure, and also you can set the limits of the size of the components on the limit gauge micrometer. And there is a depth gauge applications we can use for measuring the depth of the holes, depth of the slots and recessed areas we can measure. So in this way, so we have to conduct the experiment for measuring the length, diameters and depth using the vernier calipers, micrometers and height gauge. Thank you.